The next thing we do in Chapter 3 is deal with individual lines and their slopes, different characteristics. What this is going to lead into is right now you're going to deal with slopes, and then what we're going to start doing is building the equations of lines. And this is something that you should have done back in algebra, but it's also used a lot in geometry and a lot in Algebra 2. The reason is geometry deals very much with three-dimensional objects. Okay, like balls, walls, okay, vehicles. And the geometry behind those, or the structure and the build of those, is not lost on the object itself, because each one of these might be a moving part. A ball might be flying through the air. A vehicle might be flying down the road or driving down the road. And the next step in once you analyze the shape and the different characteristics like the area, the volume, stuff like that, is dealing with the physics behind it. And physics deals with moving objects. It's the math behind moving objects. The physics of a ball, dealing with how hard it's thrown and how far it will land and the arc that it takes to get there. A vehicle, the physics behind a moving vehicle, how much weight is behind that vehicle while it's moving. All of that deals with lines and vectors. And so you have to be able to understand what's happening. If this line right here, for example, was the representation of a truck going up a hill. At first, it's actually completely idle and not moving, and then once it gets up enough RPMs, it slowly begins to build up the hill. And so you have to understand what's happening with a line, or you have to understand what's happening with a line before you can analyze what's happening with objects as they move in physics. So in geometry, we not only study shapes and like what we've been doing, studying angles, but we'll study what's happening to an object, a geometric object like a ball, at a certain angle in time. If I throw a ball on a certain angle, what's going to happen to it? And all of that is kind of a glimpse into what you'll learn in physics. The first thing that we talk about when dealing with lines is their slope, or how much they increase or decrease over time. We can actually find what slope is by identifying its rise, meaning how much does it go up and down the y-axis, and we can find that by taking 2 points and subtracting them. And its run, or its left to right movement. Maybe this represents time. How much something increases and decreases over time. Or maybe this is elevation, and how much your truck speeds up or slows down based on elevation. But we can find that by taking 2 more points, like x2 and x1, and subtracting them. Again, should just be a review, because you were introduced to these ideas in algebra. But you know what? It's been a while, and some of us forget. So we have to kind of review. There are 4 different types of slopes you can have. You can have a negative slope, where something actually decreases over time, or it falls from left to right, as in line J. You can also have a positive slope, where something rises over time, or it increases from left to right. You can have something with a zero slope. A zero slope means there is no increase or decrease. It is flatlined. Just like a dead person has no pulse, a flat line or a horizontal line has no slope. And then you can have something called an undefined slope. And an undefined slope means it increases so fast that we can't actually measure it. It's like if we look at just line N here, okay, and we analyze what happens to line N as we increase on our x-axis from left to right. If I'm going, come on, all together now, there we go. If I go this way along the x-axis, let's look at what happens to N. It's like, oh, there is no N, there is no N. Boom! It goes all the way up or all the way down so fast we can't actually measure it. Meaning from here to here, n just went to positive infinity or to negative infinity. You can't measure something that moves straight up or straight down that fast. You might say, well, my wall at home goes straight up and down, and I can measure that. Yeah, but it doesn't go up forever. If it went up forever, you couldn't measure it. Nothing in our world, or in our universe for that matter, really holds true to this definition. Meaning there's nothing that goes up that doesn't ever come down, or nothing that doesn't go up that we can't identify. But if there were, that would be called an undefined slope. It increases so fast, so quickly, that we can't actually measure it. But that would be a vertical line. So those four different types of slopes, negative, positive, zero, and undefined, are all that you need to be familiar with. You should have seen them all in algebra, but again, this is just a review. The equation for slope is something that you should have also seen. Okay? It's considered rise over run, or the change in y, which is rise as we go up and down, divided by the change in x, which is our left to right, or our run. And we can actually use the equation y2 minus y1 divided by x2 minus x1. Now there is one thing that we have to remember. Slopes should be reduced fractions, or whole numbers. So if you have the fraction 24 over 6, that needs to be reduced into just 4. Or let's say you have the fraction 6/4. You need to be able to reduce that into 3/2. And that requires you to be able to do a lot with numbers. Notice, this is all algebra right here. The geometry is just the equation. Once you plug the numbers in and you have to solve it and reduce it, that's algebra again. Your algebra skills have to be where they're supposed to be. If you skated through algebra by doing very little work and really not paying attention a lot, but somehow got into geometry, you're going to struggle a little bit. So make sure that you take your time and ask a lot of questions, because I can explain things to you. What's nice is your graphing calculator will reduce these because the amount of time it would take me to show you how to reduce them is more than I have in this tutorial. So let's just assume that you know how to reduce fractions for now. Let's go to the next page in our notes, and we're given 4 different lines here. And we're told to find the slope of them. Using the slope equation, or the formula for slope, we'll write it up here at the top. y2 minus y1 divided by x2 minus x1. And you'll notice right away that we have to have 2 points. We'll have an x1, y1, and an x2, y2. You might say, well, why are they x1 and y1 and x2 and y2? I can't just say x and y, because I have 2 of them. Now this point is given to me first, so that's my first x and first y that I come in contact with. This point is given to me second, so I dub it x2 and xy, or y2, because it's the second x and the second y that I've been given. And so if we take y2 and subtract y1, divide that by x2 minus x1, we should get our slope for each of these lines. We're going to practice that now. Let's look at letter A, which is right here, or line A. Now, one thing that you have to be able to do is you have to be able to read a graph. You have to be able to say, well, I need 2 points. I need 2 points that line A goes through. One of the points I can say is right here. It's at 0, 3. You also need another point. Now, what you have to be able to do is say, okay, I don't want to take this point. I don't want to take this point. I don't want to take this point. I need perfect points that it goes through. Like, obviously, this is halfway in between 4 and 5. Or, excuse me, 5 and 6. This one is kind of 2/3 of the way between 4 and 5. This one is about 1/3 of the way between 4 and 5. You don't want to use those. You want to use points where it goes through a perfect intersection. So, for line A, we're going to use 0, 3, and we're going to use this intersection, or this point right here, which is 2, 2. Those are my 2 points that I'm going to use. Now, using those 2 points, I'm going to first label them x1, y1, x2, y2. That's going to help me so that when I plug them into my formula, I plug it in correctly. Well, for letter A, I need y2 minus y1. y2 is 2 minus y1, which is 3. You should be following along. I'm going to divide that by x2, which is 2, minus x1, which is 0, and so I've got 2 minus 0. Now I'm just going to use my basic algebra and solve this. What is 2 minus 3? I hope you're saying to yourself, that's negative 1. And what is 2 minus 0? I hope you're telling yourself that's 2. So I found a slope of negative 1/2, meaning this line goes down 1 and over 2, down 1 and over 2, down 1 and over 2, down 1 and over 2. You get the habit. The rise here is negative, telling me it does not rise, it actually falls. Notice how my x is still positive, so I'm still going to the right, I'm not going to the left. If I went down and to the left, well, that would end up being a positive slope. Only one of your numbers can be negative, and you'll notice that negative 1/2 is a reduced fraction. So in essence, I'm done. I found the slope of line A. I'm going to stop, kind of back up a little bit, and I'm going to go to line B. Line B is right here, and so I need 2 points that it goes through. The first point that I see is right here, an intersection. I have an intersection at a perfect point. It's 2, 2. The second point I see is where line B crosses the x-axis, and that's at 0, 2. You'll notice that whenever we label a point, we label its x value first and then its y value. This point right here, and you have to be looking up in order to see it, this point, its x value is 2 and its y value is 2. That's how we got the point 2, 2. The next point right here, and you have to be looking up, is at 0 on the x. See how that 0 is right there? And 2 on the y. Or I'm sorry, that's actually 2, 0, not 0, 2. I'm sure some of you were going, what's this schmuck talking about? The x is 2, and the y is 0. See how it's at 0 on the y? So we write 2, 0. Thank you for those of you who were correcting me. I couldn't hear you. Get it? Anyway. So we take the same equation. y2, I'm going to go through and label all these. x1, y1, x2, y2. Now I'm going to come over here and write my problem down, but replace the variables with the numbers that I have. Instead of writing y2 minus y1, I'm going to write 0 minus 2. And the reason I'm going to do that is because y2 is 0, y1 is 2. So when I replace them, I get 0 minus 2. I'm going to divide that by x2 minus x1. x2 in this case is 2, x1 is 2, so I get 2 minus 2. Now, if I simplify this, 0 minus 2 is negative 2. 2 minus 2 is 0. I want you all right now to plug this in on your calculator. And I'll even grab a calculator too. Pull it up so that you can see what it looks like. We have a negative 2 divided by 0. Cannot divide by 0. Maybe I did something wrong. 0 minus 2, negative 2. 2 minus 2, that's still 0. I did the math correct, but for some reason, I'm not able to do this problem. This problem is supposedly wrong, or you should be getting an error. Why are we getting an error, you say? Because we are trying to find the slope or the amount this line increases over time. The problem is that this line increases so fast that your calculator cannot find it. What kind of slope is that? Well, that is an undefined slope. So, when we're asked the slope of a vertical line like letter B, we cannot write negative 2 divided by 0. That is mathematically an error. The slope that we have to write is this, undefined. Meaning it is not defined mathematically. We cannot find it. There's no mathematical way to measure how fast B increases. There's no way. So we just call it undefined and move on. Let me erase a little bit so we have a little bit more room. And we're going to go to the third line, or letter C. Now, if this is letter C, we need 2 points. The first point I see is where C crosses the X and Y axis, and that's at 0, 0. It's at 0 on the X and 0 on the Y. That's where we get the 0, 0. The next point I see is this same intersection that I've been using, and that's at 2, 2. Now, using those points, x1, y1, x2, y2, I want you to go through and I want you to find the slope of line C. Pause the video and do that now. Hopefully you had enough time to find the slope of line C. And what we did was we found our 2 points, 0, 0 and 2, 2. We plugged those into the formula for slope, y2 minus y1 divided by x2 minus x1, which is right up here. And when I substitute everything in, I get 2 minus 0 divided by 2 minus 0. Well, I can simplify that because 2 minus 0 is 2. 2 minus 0 is 2, so I get the fraction 2 divided by 2. I don't want to write a slope of 2 divided by 2. I need a reduced fraction. If I reduce 2 divided by 2, I get 1. Line C has a slope of 1, meaning it increases 1 and runs 1. It goes up 1 and over 1, up 1 and over 1, up 1 and over 1. And you might be saying, Mr. Gentry, I'm able to see that just from the graph. Congratulations. If I gave you 2 points but no graph, you still need to be able to do the formula. Anybody can say, oh, it goes up 1 over 1 on the graph. It's kind of like cheating. It's kind of like cheating. It's not exactly cheating. I didn't say you were cheating. Why, do you feel guilty about cheating? Anyway, you need to be able to not only use the numbers or the points to find the slope, but you could also, if you were given a graph, you could also just count. Now, that doesn't help you with horizontal and vertical lines, as we're going to see, but anything else you could find. You could use the graph to count. How much does it increase or decrease? How much does it run left and right? And use those numbers, make sure they're reduced. You could use those numbers to write your slope. I want you to look at letter D now, or line D, excuse me, which is right here. And I want you to not only identify 2 points that it goes through, I want you to find the slope of line D. Pause the video and do that now. Hopefully you had enough time to find the slope of line D in this problem. You should have first identified 2 points on line D. I identified the first one right here, and that point is 0, 2. It's at 0 on the X and 2 on the Y, so we get 0, 2. The next point is the same point, the same intersection point I've been using, and that's at 2, 2. If I plug those in, making sure that x1, y1, x2, y2 are in the right spot, I should get the formula, or the equation, 2 minus 2 divided by 2 minus 0. Well, if I simplify that, 2 minus 2 is 0, 2 minus 0 is 2, so I get the fraction 0 divided by 2. I need to reduce that because 0 divided by 2 is 0. Line D has a slope of 0. It is not undefined, it is 0, meaning it doesn't increase. Line B increases so fast that we cannot define it. Therefore, it is undefined. Line D does have a slope. It is just 0. Make sure that you don't get 0 and undefined mixed up. If it comes up as an error, or error, depending on where you're at in Michigan, if it comes up as an error on your calculator, you know that that's an undefined slope. But if it comes up as 0, that might not be an error, that just might be the slope. So just make sure that you're doing the math correctly. That's all section 4 of chapter 3 is dealing with different slopes. One thing that we'll go over very quickly are slopes of parallel lines and slopes of perpendicular lines. I want you to repeat this after me. I know some of you are reading it out loud, good, but I want you to repeat this after me. Parallel lines have the same slope. Parallel lines have the same slope. Parallel lines have the same slope. You ready? Slope, same, the half lines parallel. Slope, same, the half lines parallel. Parallel lines have the exact same slope. If you know the slope of one line, a parallel line has the exact same slope. Perpendicular slopes, on the other hand, are called negative, inverse. You could also hear them referred to as negative reciprocals. That's because perpendicular slopes should have the complete opposite slope. If one of them is 1/2, the other one should be negative, and the opposite. If I flip this fraction over, I get 2. If I stand 1/2, if I stand it on its head, I get 2. If one line has a 1/2 slope, the other slope of a perpendicular line should be -2. We're going to talk about that here in a second. Example 2. Find the slope of a line parallel with y equals 2x plus 5. Something that you need to be familiar with very quickly is the slope-intercept form of an equation. Now, you should have already known the slope-intercept form. Those of you who don't, let me give it to you. It is y equals mx plus b. Y equals mx plus b. You'll notice that there are 4 variables in there. The x and the y are a point on the line. The m is the slope. And last but not least, the b, whoops, wrong one. The b is called the y-intercept, or where your line crosses the y-axis. The x and the y are a point on the line. Again, this is the equation of a line. If you wanted to graph a line on your graphing calculator, it would need to look like y equals something. The x and the y are a point on the line. We're going to talk about that more in Chapter 3. The m is the slope. If you notice, we just spent an entire time finding slope, or the letter m. You can even see that right here. It's denoted by the letter m. If you look at our equation, m always comes in front of the x. It's whatever number is in front of the x. And b is the y-intercept, or if I look back here, it's wherever my problem, or wherever my line crosses the y-axis. Maybe it's +3, maybe it's +2, maybe it's 0. But that's what the b represents. So if I look at number 1 here, I've got my equation. My x and my y represent a point. The number 2 represents the slope. And the number 5 represents where this line crosses the y-axis, or its y-intercept. Now, what I need to do is I need to find the slope of a line parallel with this line. Parallel lines have the same slope. If this slope is 2, then a parallel line will also have a slope of 2. And the reason for that is if I draw very quickly an xy axis, let's say that this first line, we'll call it number 1, increases 3 and then runs 5. So it would have a slope of 3/5. A parallel line, in order for it to be parallel, would have to increase 3 and then run 5 also, because parallel lines never intersect. So they would have to have the same up and the same over. That way they never intersected. If they both increased 3 and ran 5, they would never intersect. When they give me this equation, I can identify the slope of this line is 2, which means a parallel line would have to have the same slope or a slope of 2. On the other hand, if we look at number 2, we're told to find the slope of a line perpendicular with it. Again, it's in slope-intercept form, and so the first thing I can see is the slope of this line is 1/2. A perpendicular line should be the exact opposite. If something has a slope of -1, 2, looks like that, a perpendicular line should look something like this, where they meet at a 90-degree angle. Let me label my XY axis so that you can see everything. XY. And so again, if this line has a slope of -1/2, the first thing I notice about this line is it must be positive. Well, if I can take this and make it negative, a negative -1/2 equals a positive, then I'm going to find the reciprocal, or I'm going to flip this fraction over. 1/2, if I flip it over and stand it on its head, I get 2/1. So, if I make it negative and the reciprocal, I get a positive 2. This line has a slope of positive 2. If you're given the slope of a line and you're told to find a perpendicular line, make it negative. Maybe it's already negative, so your new slope will be positive. Or maybe it's positive, so your new slope will be negative. But make it negative first, then flip it over. If it's a fraction, you'll get a whole number. If it's a whole number, you'll get a fraction, and vice versa. So, when I go back to my notes, if I'm given a slope of 1/2, the first thing I'm going to do is make it negative. Then I'm going to flip it over, so I get 2/1. My new slope is a -2. I know that this is a lot very quickly. This should be a review. I'm going through it fast because it should be a review of stuff that you've done in algebra. Now, that's not to say that you did it perfectly in algebra, but you were introduced to it. The reason you were introduced to it was so that I don't have to reteach it in geometry. I am reteaching it just to benefit you, just so that you can maybe get a little extra help. So, let's kind of review very quickly. The equation or the formula of a slope, y2 minus y1 divided by x2 minus x1. There are 4 different slopes that you should be familiar with: negative, positive, 0, and undefined. We practiced finding those slopes. Then you were introduced to 2 special slopes. Slopes of parallel lines. Parallel lines have the same slope. So if you know the slope of one, it's the same for a parallel line. Perpendicular slopes are negative reciprocals or negative inverses, depending on how you were taught. So if you're given the slope of a line and told to find a perpendicular slope, make that slope negative that you were given, and then flip it over. A reciprocal is a fraction flipped over or a whole number flipped over. Really, a reciprocal is whatever you multiply something by to get 1. So the reciprocal of 1/2 would be 2. Well, we need a negative reciprocal, so we get -2. There it is. The 4 different types of lines, or 4 different types of slopes: positive, negative, 0, and undefined. Let me write these down. Positive slope, negative slope, a 0 slope, and an undefined slope. Then parallel lines and perpendicular lines. Slope. So you need to know those 6 different identities or 6 different ideas when dealing with slope. let's take a look at your homework where you're going to practice all this.